Yeah, I guess we're gonna check on topics.
Yeah.
Okay.
So everybody's here. So Swati, if you can just give quick introduction of what you've been doing here and what's your background?
Hi, my name is Swati. I am from IT background. I have completed Bachelor of Engineering in Information Technology. And recently, I have completed my Salesforce training in Salesforce Admin and Salesforce Platform, along with the certification, couple of certifications I have completed. Then I'm looking for a job as Salesforce tester, and yeah, actually, I'm looking for a job as Salesforce QA tester, analyst level.
Okay.
Thank you.
So rest, everybody's here, so we'll just get started. I'm gonna just share a screen.
I sent her the, Swati, you should have received the email link for the material online. So Dilip is going through the PowerPoint here, that should be in the same link. If you don't have it, then let me know and I'll send you.
Sure. Actually, I have received that email today morning only.
Yeah, you should have, yep. And if you go up one directory, then you will find the PowerPoint slides that Dilip is showing on the screen today.
Okay, sure.
Okay, so Swati, in the last week, we captured, filled the requirements document. So I'm gonna pick it up from where we stopped last week.
Yeah.
Okay. All right. So Thursday, we reviewed it, the requirements document. And the other aspect, we reviewed it. It's a system design document, right? So what it contains what the data design is, what interfaces is gonna be, and external interfaces like email. Okay. What is your question?
I don't have the number.
What do you do?
A notebook, you will print it.
Yeah, I'll get you. Yeah.
You don't need it filled up for now.
Oh,
Because it's filled up. Okay. So what we're gonna start looking into today is the test plan. So if you remember, like it's in the SDLC lifecycle. We started it at the planning. And then we talked about the analysis phase, that's where the requirements comes in, and we started looking a little bit in the design space. So one other thing that happens in the analysis phase is you start building something known as a test plan. So we're gonna talk about what test plan contains it, what information it does it, but before that, let's look into what it means to do a testing. Okay. So testing is nothing but a task where you run the program with the intention of finding an error. Okay. So you got all of the requirements. Let's say somebody built the software using that requirement. And all you're doing it is you're verifying it. That does that, whatever the program they've written in meets those requirements or not. Right? And your intention into doing that is to find any problem that doesn't align it with what the requirement was saying. Okay. So it also intention is to do two things, right? First one is it's fit for purpose. That means can somebody use this software? And second one is, does it do what is expected to do? Okay. So in order to do the testing, you write what is known as the test cases, right? Think about scenario. So let's say if I'm like it's building a house and I'm checking it to see if electrical system is working or not, right? There are multiple ways that I can do it. One scenario could be, I could be turning on the switch to see if the electricity flows it, like it's, for example, if I've turned the lights on, right? That's one test case. The other test case could be is I plug into the wall plug and to see if the electricity is working or not, right? So I may be doing a multiple test cases in order to test the scenario whether the electrical system is working or not. Same thing in a software world, you will do multiple test cases in order to test the various aspects of the software. Okay, in a good test case, it is something defined as, it gives you the ability to find an error, right? So something that has a high probability of finding an undiscovered error is considered a good test case. Okay. And a successful test case is where it actually helps you to find the test case. Okay. There are a couple of characteristics of a good test case. Okay. One of them, it should not be redundant. That means it tries to test a new scenario, a new possibility that happens within the software. It needs to be a best of breed, and more importantly, it can be too simple or too complex. And I want you to hold on to these three things for now. When we start writing the test cases, and on Thursday and then next week, we will actually go through a specific example to tell you, understand, so that what is a redundancy means, what does it mean not to have something too simple or too complex. Okay. And the goal for your testing should be is you find the bugs or the defects as early as possible. Okay. So it's an easier if you find the bug earlier in the life cycle of software. Okay. Let's take an example that we were talking about building the house. If you wait till end, till the house is built to do any testing, whether it meets the standards or compliance or codes, and you find an issue that, hey, it doesn't meet the foundational codes, what is going to be the resulting, right? You have to demolish the whole house, rebuild the foundation, and do it. Think about how much cost it is. Versus if somebody gave you a drawing of the house before it was built, and you find an error in that, what is the cost to fix it? It's probably the drawing, right? It's gonna be way lower than to rebuild the whole house. Same thing in the software world. Right? If you finding an error that something is not right while you're reading the requirements, what is the cost? Nothing is built, right? So you just talk it and fix the requirement. Versus if the entire software is built, then you find an issue. Then you have to rewrite some or most portion of the software, right? You have to redo the testing. You have to re-engage the people who are like, it's kind of from the user community point of view, who validated the user acceptance stuff before you can really release the software, right? Think around the cost, right? So it's always, your goal is to find the bugs or problems as early as possible. Okay. The other aspect that is, when you're building a software, there's only two people who knows everything end to end for a system. One is software architect, who essentially builds it, the component and the design. And the second one is the software tester who tests it, because they're testing everything from an end-to-end point of view, not just they have a knowledge of entire system and not just a small portion of the system. Okay. Part of the reason why we ask you to read the requirements is because you get the mental picture of how the software is going to build it, so you can find the places where potentially things could go wrong. Right? Most likely, when you think around even building a house, where does things go wrong? Probably where the things connect, right? Because that's where things usually tend to not do pretty good job or tend to wear and tear and fall apart. Same thing with software work, right? When you're looking at the requirements, that's what you see, is where all the interconnection points are. And they are most likely, that's where it's going to be a problem. Okay. Now, let's talk about the software testing lifecycle. Okay, so all of you last week understood what is a software development lifecycle, right? So think around it similar way. If you say, if I'm a quality assurance person, And as the software is built, what is the life cycle that I go through as a software quality assurance? So you start first with identifying the requirement. So first and most important part is to understand what is being built. Okay. Once you understand what is being built, the next thing you need to figure out is, how do I know it has been built successfully? Right? So there's something called an acceptance criteria. How do I know when will I accept the software? So lay it out that's an acceptance criteria. Okay. So I have a requirement in the acceptance criteria. The next step comes in is start planning and strategizing is how I'm going to go about testing. Okay. So at this point, right, all I have is not software, requirements, right? Requirements, understand it, build a plan, how I'm going to test about it. Once I have all those things, right, what is a lot of times known as test cases and test scenarios, that's part of the designing it. Once I have all of that, at some point, software development team is going to give me, here is the software. You go test it. So you take the plans that you have built it, how you're going to go about testing it, and you execute it against the software. This is where you are actually testing. Now, as you test it, remember what is the purpose? To find the errors, right? You may find some error. Right? So you look into it, track all those errors, give the development team the feedback that, hey, this is not working, this is not working, fix it. When they fix it, they're gonna give you back, you're gonna retest it. Right? You're gonna track it. Did they fix all of those things or not? And at some point, either you're gonna run out of time or you're gonna finish all of your testing. Okay, at that point, you review it and make sure, did you test everything? What is working, what is not working? And then you share that information with your project teams and your end users who are paying for software, right? And at that point, they're gonna decide it. Hey, is it good enough? Then I will accept it. At that point, you become a baseline that says, okay, the software is working. Here are the test cases that are working against it. Here are the ones that didn't pass it, but they accepted the defects and said they will work with it, and then go with that. So at that point, it becomes a baseline version. And then if you get additional requirements or features, then you restart the cycle. Okay, any questions? Here's the another view of what they talk about, how things map between the software development lifecycle and software testing lifecycle. So think around R4, right, where you read it. So initially what you get is you get the requirements. Right? As you get a requirement, you start building in what I talked about it, right? You start thinking about what will be the acceptance criteria and what I would test it. But at this point, you don't have any other information other than what the requirements, right? So you treat everything as a black box and plan it how I'm going to do the user acceptance testing. Okay, so in here, right, you have a requirement, you build the UAT test case. The next step, the architect is going to do it, the designer, lead designer is going to take this requirement and says, I'm going to break it into the functional decomposition. Right. So if you look into our flow, right, it broke it down into 6 or 7 different components, managing users, managing the dealers, managing lenders, right? So each one of them is a function. So now they start building a functional specification of each one of those. So as that get defined, what you do it as a tester, they start identifying what each of the component testing or system testing is going to look like. Then you take it, that piece, which is a high level functional decomposition, and says, okay, I'm going to break it down and going to write technical specification. In other words, what should be the behavior of managed users? what other component it interacts with, and how does it interact with that. Okay, so at that point, in order to test that, you start building something known as an integration test or a link test. Okay, so as a team, you start building that. Then you take it one more further level and says, okay, I'm gonna do it like it's, let's say, add a new dealer. Right, that's part of a big dealer management. And then that add a dealer, I'm gonna write it down specific details of how I'm gonna go about writing a program to add a dealer. Okay, at that point, it's the smallest unit, so you start building unit tests. Okay, now as a quality assurance people, you're not doing all of this, but we'll talk about it. But that's how the testing lifecycle happens. You start from a broader picture, and as things gets refined, you get further and further detail and a smaller and smaller test piece. Okay, once that program specification is done, somebody in the development team is going to write the code. So now you have the actual concrete keys that you can run the test against them. At that point, you go into the reverse order. You take the unit test and execute against the code. Make sure the code meets that particular smallest level of testing standard. Once that passes, you try to do the integration. Does that work with the other component that it's supposed to interact? Then you take that integration test results, if it's successful, and you start doing it, does it work holistically as a system? And if it works then you just hand it over to your user and say, now it's ready for you to validate and test it. Does the system work as expected as well? That's from a user perspective. Okay. So that's something known as a V model. So a lot of times you will see it either the entire life cycle. This is from a tester's point of view, or you will see it as what is the testing needed in order to the system. This is the whole life cycle for that. Okay. Any questions so far before we jump into the test plan? What does it contain? Okay. So as the development team starts building out the system design document, your testing starts writing what is known as system test plan. Okay, so you have a requirements document, and then one team starts writing design document, other team starts writing how we're going to go about testing the system. Okay. If it is a big project and which has multiple quality assurance people, then you will have one test lead who will take the lead to write that. If it's a small project and you are the only person who is performing QA testing, you will write this test plan. Okay. The good thing is that once the test plan is written for one project, it's about 70 to 80% of it, essentially replicating it from one to another. So it's not something that you write it from scratch every time completely. Okay, but let's talk about what is the intention of a test plan. What is the goal? The goal of test plan is to identify what testing tasks you need to perform. Also to understand it is who all will be part of it, right? So assigning resources, and resources, that means people, process, and computers, right? Computer resources that you can put in. Then you also identify how long you think it's going to take every task, right? And what are the processes you can use it in order to do the testing? Okay, and the whole purpose of that is how are you going to go about to validate the acceptability of the test system. So what does it contain? It talks about the scope, right? We saw it, the functional and non-functional requirements. So it may talk about scope. Hey, the scope for this particular test is just the functional testing. Or it may say it's both functional and a non-functional testing, but it may not include the load and performance. So there is a various level of testing, and this test plan essentially identifies the guardrail around it. What is the scope? What will be the approach? How long it will take it, and how many people and the resources that will need it. It talks about what features I'm gonna test it, what are the testing tasks, and what are the risks. So often, let's take an example. If I'm building a house, right, one of the risks could be, hey, it's the weather, because it's right now, it's just getting off the winter season and coming spring, so there will be a lot of rain, right? So when there's a lot of rain, they may not be able to build the frame or build the foundation or build that, right? So chances that my project get delayed. I may have to deal with the risk, right? And the risk could be is, hey, I was planning to move it in the house at the end of June. It's not gonna get done in June, so I may have to find a temporary place to live till that house is built, right? That's called a risk contingency plan. Same thing in the software world. I was planning to do the testing starting this day, but the development team didn't finish its software development. Well, what risk I have? How am I gonna deal with that risk? All of those things is identified in this plan. Okay. It talks about what tools you will use. Okay. Is there an off-the-shelf testing tool? Are you gonna build something? Or are you gonna do all of the manual testing? And where are you gonna record it? How are you gonna track the defects? How are you gonna identify how many testing are completed? What are the results for each one of them? All of that is kind of stored somewhere in some tool. When it talks about the deliverables, how are you gonna notify people how your testing is progressed? And where would people see it when things is done? Okay, it talks about the procedures, standards, and documents, right? And the document part is more important because it talks about what is this test plan based on? Specific version of the document, right? Requirements document. Because if they give you a requirements document, you build a test plan, and if they change that requirements document, right? Most likely, your test plan needs to be updated. It's no longer valid, right? Because something was changed. So it's important when you put the test plan, you identify, hey, this test plan essentially coordinates and refers to this version of the requirements document of how it needs to be tested. It also, at a high level, talks about the test scenarios, right? So let's talk about those two terms. The test scenario is a situation that you identify to test a given function or functions of software. So you may have a test scenario called create a debug. Okay, it talks about all the different things that you need to test it for creating a dealer function. Then you may also have test cases, which is, hey, I'm going to try to create a dealer with providing them the state information and account information, right? Because remember the franchise number they talked about needs a state and accounting, create the franchise number. So you say, hey, I'm going to do that one test case. Another test case I'm going to do it is I'm just going to provide a state and not provide accounting and see how system behaves. Right? So they both are part of creating a dealer scenario, but it has multiple test cases. Right? It's individual possibility within that scenario. Okay. And then in order to do that, you write the test script, which is literally step-by-step instructions. What I'm going to do it to do that test case. Right, so if you think about progressively scenario, case, and for every case I have scripts. Then it talks about the metrics. Okay, so as you test it, you can think around two different types of metrics, the product metrics and a process metrics. Product metrics talks about how good is the product, how many defects you're finding, and so on. Process metrics talks about I'm using testing process, how effective is my process finding the bugs? Now let's talk about the characteristics of test case. What does it contain? It contains what input you're going to provide it. What will be the conditions? So what is the state of the product or software it is when you're trying to do this test? And then what are the expected behaviors? So let's say you're trying to log into the system. Right? Your input probably it's going to be your user ID and a password. Expected behavior is if it's a valid user ID and a password, you expect it to get logged into the system. Right? So every test case is going to have your input, the conditions, and the expected behaviors. Okay. This again, the things that we talked about, a characteristic of test case is to find a defect, right? Your good test case is your higher probability of finding a defect that was not discovered earlier. Another aspect of good test case is that it provides unambiguous results that you can inspect. Okay. So in the login example that we talked about, right, if I provide a user ID and a password, it gives me clarity whether I was able to log in or I failed to log in. There is no in between. Right? So one of the things we talked about for requirement is 3C and T, right? T is the testable. That means can I test it? When I test it, does it give me a clarity and did it meet the requirement? Yes or no? Simple, as simple as that. Okay, so then that's a good test case. Also, another aspect of test cases, if I give the same condition in the same input, I should be able to repeat it. And it should be predictable. That means every time it should give me the same results. Think around an example of a calculator, right? If you do 2 plus 2, it should give you 4 as an answer. If you repeat it over and over again, it should give you exact same answer. If it gives you any different answer, then can you rely on that calculator? You can't, right? Because it's not giving you the right answer. So make sure all of your test cases are repeatable and predictable. That gives you whether there is a consistency and stability in the system or not. Okay. The test plan also talks about the test standards. Okay. There is no industry-wide standard. If anybody tells it there is a standard test script that everybody uses every time, that's not true. Depending on the system, you will have different processes, different documentation. Now, you may have the same guardrail or test techniques, but you cannot have the same standard. So for example, if I'm building a tech software, right, the scenarios that I will test is going to be different than if I'm building a online retail system, right? Versus if I'm building an automated car software, which allows them to drive the automation. Right, each one is going to have its different, but techniques, it's more or less going to be the same. Any questions so far? Okay. Another thing that you talk about in the test plans is your environments. What is the different environments in which you're going to perform testing? Okay. In a broader category, there are 3 environments in which software resides. Okay. The first environment is actually a development environment. This is where developers start building the software. Okay. It's constantly changing, right? Because they are still experimenting it, building it. Therefore, it's known as a sandbox or development environment. It's kind of like a sand, right? So if you go look into the kids, right? When they're like it's playing in the sand on the beach, they are like it's building it and breaking it constantly. So till they are satisfied that hey, this is whatever the structure they're building in the sand, to feel confident. Okay. Then the second environment is known as broad category of test environment. Okay. There's going to have a different flavors of it. If you recall it, right? Right, that we talked about, the different types of testing, right? Each one could occur in a completely different environment. Okay, so you may have a system test, integration test, or an end-to-end user testing And I will also talk a little bit more on the load and performance testing a little bit in a moment. But all of that could be in a single environment. By time slice, people say, hey, from 8 to 5, I'm gonna do an integration test. Then I'm gonna do an end-to-end test from 5 to 8 in the night. And then I'll do a load testing. And the UAT testing, we'll do it once the software is ready, then we will not do any more testing, we'll just do it on UAT testing. Okay, or you can have a completely dedicated environment for each one. And then once your test software is complete, and you are ready to test, everything is working as expected, then they typically put it out into a production environment, which is a lot of times known as the lab environment. So as a tester, you're going to be focused more on the middle, the test environment. Okay. Occasionally, to mitigate the risk, you say, hey, you know what? I will access some information into the test development environment, or if I don't have enough information, I may access into production environment. But be very careful while doing this. Think about it, right? You don't want a live production environment where you're changing or deleting things. Think around it. If you're it's doing a banking software testing, right? Let's say I'm trying to build a new one. And one of this functionality I'm building it is under certain scenario, I may want to it's allow your end users to deactivate account or delete their account. If you accidentally do that into production, what are you gonna do? You're gonna actually delete the accounts of the real live users, right? Would you be happy if somebody deletes your bank account? You won't, right? There's a lot of issues with it. Hey, people will be unhappy, there will be reputational risk, there will be a regulatory risk. People can get fined. So you don't want to test it anything in production as much as possible, because there's an inherent risk for it. Same time, if they're trying to build it something in the development environment, and you start testing in there, remember, they will be restarting it, fixing things, restarting it type of thing. You're in the middle of test, you can't guarantee what they have changed. You can't predict, right? So whatever test you do, it may be working in the morning and may not work in the afternoon. But you don't want that scenario either. So most of the times, you want to make sure you are within your test environment. And not testing anything until actually something gets delivered to you in your environment. Another thing that test plan contains is test data. So when you're trying to do something testing, you need to play around with the data, right? What data you're going to use it, who is going to provide the data? Let's say if you're trying to create an outflow and you're trying to create a dealer, somebody has to provide the data that, hey, what should be the dealer, where they're located, what are their addresses, what services they provided, and so on. Because all of that data is going to be utilized when you write the test cases and scenarios. Okay. Sometimes you get the data provided by the user and says, use this kind of data. A lot of times you have to come up with your own data. And that's why it's important to identify what strategy is going to be used. Are you going to get the data or are you going to build the data yourself? And if you have to build it, that is an extra tax, right? That's some more time that you need to allocate it in your testing. Okay. The more important thing is your test data should support both positive as well as negative test cases. Okay. Positive is essentially, hey, I'm going to try to do it the way its system is supposed to work. The negative test case, I'm going to try to do it. What if the user don't provide all the data? What happens? Okay. Then it talks about what is the execution strategy is going to be. Is it going to be automated or is it going to be manual? Okay. And how we define manual test and automated test. Manual test is something which requires a human interaction. Okay. So if you're it's taking it here are the whole scripts, and then manually taking one step at a time and performing whatever the action that the script talks about. That's a manual test. Okay. Pretty much most of the systems, when you started building it, all of the user acceptance testing are going to be manual testing. Because it tries to mimic the way the user is going to use the system. Lot of initial system testing, integration testing, and end-to-end testing is also going to be manual. Okay, everything starts manually, and then you can automate it using some of the tools and script it. Okay. Versus automated testing is something that is scheduled to run on a predetermined time without any human interactions. Okay, you will hear a lot of times as the systems are getting built, they will have an IT process that runs it and tests all of the test cases against the given piece of software and identify the results. So that the developer, when they come in the morning, they say what was broken last night based on their development work, and then they can go and fix it versus what was working. A lot of times you will have a periodic testing that you run it to make sure everything is still working as expected whenever the new software patches on the operating systems or the working environment happens.
So for automation testing, do you need to have code knowledge?
Yes.
Okay.
So typically, that's why it is considered by IT department to test the capacity of the system.
Mhm.
So for example, like it's when you, when I was part of the telecom, we'll run what we call as continuous testing cycles around 911 systems,
Mhm.
right? Those are critical. You don't want anybody to even accidentally break anything.
Mhm.
Right, so we had an automated test suites where constantly were running against those to make sure everything is working as expected.
Mhm.
Because people's life and death is going to be involved. Okay, typically, you will have three different types of automation you can perform. One is a code driven, right? You will hear it a little bit later in the session, towards the end of the course, something known as acceptance test driven development. That means you write the test first, right? So it's everything is code driven. The second aspect, you can automate it as user interface. Right, so I write the manual test, everything is working, I use some sort of screen capturing tool to run it and protect it and says, is this working as expected or not? We'll do that test also. And the third area of automation is API based. Okay, so I'm testing it through the interfaces. So example we talked about as an Amazon, right? So if I'm doing a checkout, right, it goes to some payment gateway, some other company stuff, right? It's all through something known as an application programmable interface. So I can automate those tests because it doesn't require any human interaction. Right? I can write a whole bunch of scripts and then invoke those scripts to go out, provide that input, get the data, validate it, and see if it's working or not. Now, it also, the test plan talks about the test velocity. Okay. Think of velocities, some unit of work over some unit of time. Right? So in this case example is how many test cases write on a daily basis, or how many test cases I execute on a daily basis. What will be my velocity? Right? So it talks about that and gives you an idea of how much time I needed in order to do the testing, script writing as well as execution. Okay. Then it also talks about what kind of reports you will be producing throughout the process. And part of the reason is, as the software is getting built, right? Your stakeholder wants to understand how it's progressing. Think around, if you're building a house, and the builder says it's gonna take you 6 months to build the house. Okay, but they don't give you any update. Go ahead and says, I'll let you know at the end of 6 months. At the end of 6 months, if he comes in and says, oh, 3 months were in winter, there were a lot of rain in 1 more month, so at the end of 6 months, he comes and says, oh, I'm gonna take 4 more months. Will you be a happy customer? Right. You will say, I want to know on a weekly or a monthly basis how it is progressing. Are you gonna meet that timeline or not? I wanna know. Right? That's what the purpose of all this test report does. It gives you an indication of how the system testing is progressing it. Are you good with that, right? So it talks about what is the progress and is it quality? Right? You've been testing it and pretty much everything fails and you're able to find bugs for when you run every test. What is going to tell you the quality of the software? It's very poor, right? That means it's going to take you more time for developer to fix it, more time for you to test it, therefore it's going to be delayed. That's what the most important part of the test report is. Am I going to get my software on the time that I'm expecting? Some of the things that you report as part of the test report is how many functions are working, how many defects you have identified, how many of that was fixed, how many defects by each one of the components, right? So defect distribution. Also, it talks about how long it's taking you to fix those defects. Is it taking it 1 day? Is it taking 2 weeks to fix every defect? What is the average age of defect? Then it also talks about what is the percentage of functions or test cases that you've done. How many you tested, how many passed, how many still remain at testing. Those are the details, right? For each one of the things that we talked about. What is the average age? How many defects are outstanding and how long have been? What is the severity type of it? Where are they mainly focused on? Is the defect more on your interface, on a database, or is it API? How long it's taking you to do it? Okay. Then it also talks about what are the test severity standards you're going to use. Okay. So every time you identify a defect, there's going to be severity levels associated with it. Okay. Some are going to be very critical. It says if you don't fix those defects, you can't proceed it further. So let's say, for example, you build a system where everything has to be logged in first. And without logging in, you are not able to continue doing remote testing. And if your login is not working, and you're not able to make any progress on your testing, it's critical, right? It's preventing you from it. Another example of critical defect is, let's say you're doing a credit application. And social security is the key for you to enter it as required information. And if the system is not accepting social security number, or it's not able to validate it, that's critical, right? Because you can't test any of the other loan functionality unless that works. Versus something could be a minor. Hey, the test box should not be at the top left corner, it should be on the top right corner. Test box is there. You can still continue to do the testing. It's not just in the right place. That's probably a minor. Something might be a cosmetic. Hey, the background on the page should be green. It is not green. It is white. It's cosmetic. Is it impacting any functionality? No. Is it impacting any user interface? It's not even like it's a box in the wrong place. It's just that the background is wrong. Okay. Then there is a priority aspect also comes in. Okay. So the criticality talks about what is the important, what is the impact of it. The priority talks about which one is high, which one is medium, which one is low. This talks about which one you should test first. If you don't have enough time, what functionality you need to test first? Those becomes a high. What functionality you can test it later, it's not as important to run it. That's a low. Right? So you need to have both the test severity and the priority in order to understand the whole picture. Then we talk about the metrics, right? The product metrics and process metrics. So product metrics talks about the effectiveness of the software. And the process metrics talks about the effectiveness of the tools and the processes. So for example, one of the product metrics could be the user participation. How many times user participated versus what is the total test time? Path tested, this is another product metrics. How many paths are possible versus how many are you tested? One of the process metrics is cost to locate the defect. How many test cases you run it before you could find a defect? And what was the cost to run those test cases? Right. Here are some of the test tools that you will utilize it as they go through it. Okay, and like as you go through it, we'll talk about the tools, we'll use it tools starting in a week or so. Okay, so in your folder, right after the design document, there is a test plan document. Okay, what I would recommend is for you to take some time this week and read through that test plan. Okay, and let me know if you have any questions. Now, one of the important things that you do as you go through the test planning is trying to understand the estimation, how long it will take you to do the testing. Okay. So I'm going to run a test now. I'm going to ask you a couple of questions. And then we'll do the same exercise when you're done with the course and ask the same question. Okay. So all of you read the requirements document, right? If I come to you and say, great, you read the requirements document and you are responsible to test it, how long do you think you will need it to test the system? So Solar, if I come and ask you, you have that requirements document and you are in charge of testing that to ensure that whatever the system we build it meets that requirement. How long do you think it will take you?
That's like,
Functional testing, let's say keep the scope to be functional testing. How long do you think it will take them?
1 week,
How many?
1 week.
1 week? Okay, what about you, Nana? What do you think it will take you?
Two weeks.
2 weeks? What about you, Gene? Hmm?
I don't know.
You don't know?
Mhm.
But if you were to guess it, how much do you think it will do?
Maybe 1 week, 2 weeks.
Okay, what about you, Pooja?
1 week.
1 week. So you all kind of give rough estimate, right? What it was based on it? What criteria you thought you used it in order to say it's gonna take me 1 week? Versus Nana said that it's gonna take me 2 weeks.
What's the question again?
You said it's gonna take you 1 week, right? There must be some thought process in your mind, which led you to, hey, it will take me 1 week because I need to do this, this, this. Right, what are the thoughts? What were you thinking? The task that you need to do it, that'll take you 1 week.
Yeah, because I need to understand the requirements. I need to make sure that what the end user, what the customer needs, it's actually placed into the requirements.
Okay.
So,
So the reason why you say let's take 1 week, because first you need to understand the requirement,
you're right,
then you will test it,
they're not tested.
right? So it's roughly the same process, right? Everybody had gone through and everybody's smart. Okay. So there's typically templates that you use it in order to get the estimate and say how long it's gonna take. Okay, so let me see. So. The way you're trying to do it. Right, is to first understand what are the different, how many scenarios you need to build. How many test cases, right? So once you understand the requirement. You're gonna do some mapping, talk about how many scenarios I will need it. What are the different test cases and what is the complexity, right? Some scenarios may be simple, some may be complex to do it. Then you take that information. And then you put in some sort of templates, right? So just like what you talked about. How long it's gonna take me to analyze the requirements, understand the requirements. Then we talked about writing the scripts, right? Writing the scenarios, writing the test case. It's gonna take you some time to write the scripts, right? So if you remember in SDLC lifecycle, right? You understand the requirement. Then you identify the acceptance criteria. Then the next step is planning and designing, right? How are you gonna go ahead and plan the testing for this? That means how many scenarios, what are the test cases, what are the test data, and you're gonna write all the test scripts. Then you need to identify the execution time, right? So how long it's gonna take you to do the design, and how long it's gonna take you to the execution. And remember, once you execute it, that doesn't mean everything is gonna work first time, right? You're gonna find the defect, you're gonna go fix it, and then fix it, you're gonna retest some. Right? So it's gonna take it that, then you're gonna give a user acceptance testing, and while the end user is testing it, they may need some help or they need some support. Okay, so you come up with it. You put all of that data. And then this one, the system that we talked about, roughly takes about 67 days to test it. And when I convert 67 days into a calendar week. And it's about 13 to 14 weeks, so it's roughly about 3 months. That is what it'll take you to test the R-phone system. Okay, but I wanted to get you a gut check. This is our estimate, and you will see as we go through it, why it takes us this much time. Okay, any questions? Do you understand high level what it requires for the test plan, why you need it, what it covers? Okay. Now let's talk about a little bit more about type of testing. Okay, so as you start doing testing, you're gonna hear a lot of terms. What kind of testing you're doing it? Okay, so we will go through each one of those. Okay, the intention is you understand as we go through this component, what are the different types of testing, who performs it, and when does it get performed? Okay. Let's start with it, right? So the first thing you will gonna hear it is two different terms. One is called static testing versus dynamic testing. Okay, let's talk about what does static testing means. Okay, static testing is type of implicit testing. It's a testing that you do it without executing any piece of software at all. So you don't need a product working for this type of testing. Okay, typically talks about the reviews, the compiler or inspections. So when you started reading the R-Flow, right? I ask all of you to do one thing, right? Validate a 3C in a key. That's type of a static testing. Right? I ask you to review the document, inspect it, does it meet the 3C criteria? It is complete, consistent, and correct. Right? When you did those three things, you actually did a static testing. And then I ask you, once those things are done, make sure you can test it. That is it testable? Can you do some sort of activity and say, yes, it works or it doesn't work? Okay, that's a static testing. Another thing the developers do a lot of times is they write a piece of code and then give it to somebody and says, can you review the code and make sure that it's working as expected? Without running any testing, so they will do a code review. That is also another type of static testing. Okay. The developers, when they write the code, they have to run something called a compiler. What it does is, it takes it, the piece of software they write it, and validates it, does it meet the necessary syntax, right? Similar to English language or any other language, right? Which has a structure around it. Same thing, the software has a structure around it. And you run through compiler without executing it to just say, does it meet the structure or not? That's a static testing. Okay. The whole purpose of that is to verify, is it something gonna work as expected? Can I verify it? Can I verify the requirements is complete? Can I verify requirement is consistent? That's the whole purpose of it. Now, this one gets executed throughout the software development cycle. So it's not just at one place, there are multiple points within the software development lifecycle where this thing gets done. The other side of the static testing is called the dynamic testing. This is the testing which will require to actually run the software. And the purpose of at this point is to validate it. I'm validating, is the system meeting those requirements? One is static is verifying, is will the system do what I'm expecting it to do? Validating is the system doing what I'm expecting it to do? Okay, and then this will be done when you're trying to do the functional testing or non-functional testing. In order to do this testing, you actually need a working software that you can run it against it. Okay. These are typically done from the execution point onwards, all the way till the implementation and acceptance phases. Okay. Then another term you will hear it is a black box testing. Most of the testing you will do it will be a black box testing. But black box, it means you don't know how the software is implemented. All you know is what input you're providing it, what output you get it, and you understand what is expected behavior should be, and then validating it. You have no knowledge what language the software is written, how it is written, what kind of architecture is used. That's called a black box testing. Okay. Typically, this thing is done by the testers. A lot of times you will hear another term for the black box testing called specification-based testing. They give you specific specification, says, here are the inputs that you need to provide, here's the output you should expect it. Go run the test and say, does it do it or not? Okay. Opposite of the black box testing is a white box testing. That means it's a testing that you do it because you know how the software is written, how the structure is written. Typically, white box testing is done by the developers because they know exactly how they implemented the software. What are all the possible paths the software can take it? And they're writing the testing to make sure it works for every path. Okay. Then you're gonna start looking into the B that we talked about, right? At the bottom, when I have a code, what is the first one? Unit testing, right? The intention of unit test is to perform the testing whether a small section of the code is working as expected or not. Okay. Typically, it's done in the development phase. And it's done by the development team. It's not done by QA. Okay. Also, This one you can relate it to a white box testing, right? Because I know exactly how the code is written and I'm trying to write the test to see if the code is working as expected or not. Okay. Then the next step up we talked about is the link test or integration test. Even for this thing, I need to know how the component is written, how the component is interacting with the other component in order to integrate them. So this is also some sort of white box testing. And it is testing all the integration scenarios. The reason why it's white box testing is because I know what are the different possibilities or different integration ways that it's going to work on. Okay. And it's done still in the development phase, typically towards the later part. Once earlier I'm done doing unit tests, and when all the components are working, I'm trying to bring them together. So that's in the later part of the unit test. It's again done by the development team, not by the quality assurance. Okay. I'm gonna skip those two, and I'll come back in a moment. The next step in the V we talked about was the system test. Okay. I have my components working. Now bringing all components together to see if it works as a single system. This is typically now trending going into the black box. It is now functionality of the systems. It's done in the testing phase, and this is where you step in as a quality assurance and start doing testing. Okay, so it's typically performed by the test team. Then, as you perform the testing, you're gonna find bugs. Right? You're gonna give it back to the developer and says, hey, this particular thing doesn't work. They're gonna go in, they fix it. They're gonna give you a new version. It says, here's the new version, test it again. Okay. When they give a new version, you need to make sure while fixing it, they didn't break anything else that was working before. That means you have to retest things that was working before also. Okay. When you do that, that's known as a regression test. Okay, so the purpose of regression testing is to verify the part of the software that was working before, it is still working in a newer version that they gave you. Okay. This thing is typically done by the testing team in the test phase. Okay. Think it out, right? They gave you a new version of software. That means it's now back in your domain. It's in the middle segment, right, that we were talking about. It's ready to test. So you test it again. That's called regression testing. Now let's go back to the two that I skipped it. The sanity testing and the smoke testing. Okay. When a developer gives you a new version of software, the first thing you're gonna do is perform some sort of sanity. Is it good enough for you to get started testing? Even before you do any of the system testing or regression testing. Right? You're trying to make sure all the components that are given it are working components or not. That's called sanity testing. Right? One perfect example is they said, hey, you go ahead and start testing it. The new version of software is available and you can access it at this URL. The first thing you're going to do is you're going to go to the URL and says, can you even see a system there? Let's say if I give you R4 and say, go test it. Here's the URL. You go to that URL and you get in a page not found error. That means you can't do any testing. Yeah, you gave me a software, but I can't even access it. Right? So the process of you just going to that URL and checking it is, can you even bring it on the page or not? It's called a sanity testing. Typically, it's done when a development team gives a new version of software into a test environment. So this is typically done by testing team, and it's done in test environment, and it's in testing. Then the next phase, you do it what is known as a smoke testing. You can pull up the web page. Right? But you know, from the system design document, that it was a multi-tier architecture, right? That means there's gonna be an application tier, there's gonna be database tier. Just because your home page shows up, that doesn't mean everything is working and ready for you to test it, right? And what are you gonna do? You're gonna just probably gonna do a simple login into the system and see if it allows you to log in. Pulls you up the pages that you expected to see here. Allows you to access the database. Right, so making it sure all the components are at least working as expected. For you to begin testing, right? Not functionally, but are they up and running as expected so that you can continue testing? That's known as a smoke testing. Okay. Are all the components of systems are working? Okay. And this is also done by the testing team in the test environment to verify the build and all the components they gave you working in so that you are ready to test it. Okay. So think around, it's a little bit of difference than a sanity testing, right? Sanity testing is, can I start testing? Smoke testing is, do I have all the components needed in order for me to do the testing? Okay, any questions? Okay. So then you talk about the functional versus non-functional testing, right? The functional testing is the features or capabilities of the system. For example, is the managed dealer working? Is the managed dealer working? Is my credit application working? All of those are functions of the system. When you're looking for those specific functions and says, are they working as expected or not? That's known as a functional testing. And it's typically done by testing, because that's your main core, right? When you're doing the system testing, what are you doing? You're doing a functional testing. And it's performed by testing. And it's done later in the development phase, early in the testing. Then another set of testing is the load and performance testing. This is a lot of times known as a non-functional testing. Okay. So one of the requirements in the art loan was I should be able to work in the system as 50 users can log in concurrently. Right. So you want to make sure, can 50 people log in at the same time and work in the system and still get the same response time? Everybody has done some sort of Black Friday testing. Shopping, right? When you go in, a lot of people are like, it's logging into it, right? Sometimes you get the same response, just working as expected. Sometimes the system is very slow. It takes you forever to get the response, right? The reason is because the system has more load than it was designed for. So how do you test it beforehand to make sure the system is going to work to the expected load or not, right? That's what the load and performance is. It's the purpose of making it sure, can the system still behave it under the expected load? Okay. Talks about making it sure system is going to be stable and perform. And thing is not going to integrate. This is typically done later part of the software testing lifecycle. Think about it. If I don't have functionality working, is it worth it even trying to test it? Does it work for 1,000 users when it doesn't work for one user? Right? So typically you don't do it unless you say, yes, it works for one user, everything is expected. Now let's ramp it up and test it for 1,000 users.
Mhm.
Does it work as expected? So this is typically done by performance testing. Now, this requires some specialized skills, some programming, right? If it's like 5 users, yeah, you can sign up 5 users. It says, hey, can 5 of you log in at the same time and perform things?
Mhm.
But if it's like 500 users, 5,000 users, right? You can't expect find 5,000 tester to run it. It's from a cost point of view, it's going to be prohibitive, right? So that means you simulate those users. that means you write a program. So this one, it's not gonna be manual, this is gonna be more what I talked about is, right, automated testing. You're gonna write the scripts, you're gonna execute the scripts. Then the next type of testing is called stress testing. Okay. Now, this is a little bit different than the load testing. Load testing is done through making sure system works as designed under the expected load. The stress testing talks about at what point the system is going to fail. So we keep adding users or keep putting the load into the system till the point when it fails. And it talks about what is the reliability and what are the workloads that system can handle, not what it was designed, but what it can handle. Okay. Typically, it's done during the later part of the testing phase. Okay, it's performed by testing. And it's not always done. Because this is an expensive, you're breaking the system. Okay. So if you want to like actually look at some of the example of stress testing, is have any one of you seen the movie called Apollo 13? Apollo 13?
Mhm.
So back in 1970s or late 1969s, NASA was sending humans to the moon. So Apollo program was like it's designed it to send the humans to the moon, do the exploration on the moon. The 13th mission of that was called Apollo 13. So when they sent that mission, there were 3 astronauts on it. On the way from here to the moon, right, there was an accident within the ship, right? And the whole movie is around how the accident was and how NASA actually worked to bring the humans back to the Earth alive. Because it's not like, hey, the car broken, let me get out of the car, fix the car and do it. You are in space, there's nothing, you can't get out and fix the car, right? How do you bring the people back? So the relationship to stress testing is what they did it is after the things was broken. So after the explosion happened. And the spacecraft was crippled. In other words, it was not functioning as expected. And it happened on the way from here to the moon. So they talked about what did to do it to bring the 3 people who were on there alive back home. Okay. So what is your immediate reaction, right? The immediate reaction is, hey, look, it's broken, turn around and come back home, right? But they determined that the best chances was not to turn around and come back home, but to actually go to the moon and take moon's gravitational shock and bring back them home through that. Because then they get an additional assistant of the gravity, an expulsion in order for the spacecraft to get the needed things. But in order to go all the way, right? They said, hey, there was not enough oxygen left because of the explosion. There was obviously human breathe it, the carbon dioxide gets produced. Some of the functions are not working. So how do you do it? They had to shut down all non-essential systems on the craft. But then you have to worry about it, right? Is you turn off. But in order to land back on Earth, you need all of those systems up and running. So what if it doesn't turn on? Then you don't come back to it, right? So they had somebody, one of the other astronauts actually work on a simulator on the ground. And doing the stress testing of, based on whatever they thought that's left, there was stress testing at what point it will break it. Because their goal was not to break it, because if it breaks it, those 3 people don't come back home alone. Right, so trying to do stress testing in terms of at what point it'll break it, so they kind of take it the system all the way to just before that point. So that system still stay functional. So if you get a chance, take a look at it. It's a good from thinking around stress testing, what do you do? Right, so in case of Amazon example, right, Black Friday. They expected, hey, you know what, probably you're gonna have 100,000 users logging into Concurrently to do that. Can our system handle it? Occasionally, they'll say it's okay, it's designed for 100,000 users. But sometimes more people are gonna log in, so at what point it's gonna break it?
But that's very risky, isn't it?
That's why it is important, that's why it's an optional. right?
Option.
It's a very expensive testing. Right, because you're breaking the system, you have to reset all the systems and then do that testing. As long as it's only software involved, it's great. Sometimes it's not just the software, right?
Mhm.
Right now, NASA is doing testing to send back the humans to the moon and to them. And as part of those engine testing, and they do it, at what point it fails,
Mhm.
right? So when you put those stress testing, when engine fails, it's not just the software, right? It's the physical hardware also that it costs. So it's an expensive testing. And typically it's not done unless the business plan calls for it. And this is usually done by a specialized team. Maybe the same team as a load and performance team, because they gradually increase the load to see at what point it's gonna fail.
So then you have to start all over again if it.
Every time it fails, then you get started.
So how does it, how does it relate with the software development and methodology, like the agile, the
Still works, right? Think around it. This is in the testing phase, irrespective of how you build the software. That's essentially it. The testing, this is what you do, right? So when you talk about agile, right, it's every small component, when you're doing stress testing for every component. So every release you will run this test. If you're doing a waterfall, you finish the whole system development and then you will run.
Yeah.
But it'll still be the same. Like, it's still the same process, just that the scale is it running in a small piece, we're running on the entire ledger. And then the user acceptance test. Okay. After everything is done, you start doing a user acceptance test. So at this point, my software is working as expected. Okay, I've tested it, now it's ready to be handed over to the development team. I'm sorry, end user. Because then they're gonna do it, what is known as a user acceptance testing. So when can you do this testing? Right, you're gonna do this testing once you are done with all of your functional testing and the non-functional testing, right? Occasionally, all of the loaded performance is done, everything is working, and then you hand out to the user and says, we've tested it, it's working, can you test it out to see if it's fit for you? Okay, it's done during the acceptance phase, right? So I'm done with all of my testing, I'm ready to baseline that point. It's typically done by the business users, but occasionally business user says, hey, I don't know all of that, testing team, can you do this on our behalf? You write the test cases, we'll review it, but then you run the test. So it's either done by the test team or the business users. Then you're gonna have certain thing known as a back-end testing. Okay, so there are parts of pieces sometimes the system has it, which does not have a user interface. So for one of the example, if you read it into the requirements document, one of the non-functional requirement was auditability,
Mhm.
right? Every time anybody makes any changes to the credit application, it needs to be captured and stored into the database, what change made it, who made it, when they made it. Right, because of the financial regulatory requirement. You're not gonna see it from the system's front end, right? So if I log into our phone, I'm not gonna see it, who all made changes, what all. So I may have to log into the database. And run a query to do it. Hey, I just made that change from the application. Did it track it? Did it save it? What all the information, right? So that's what the backend testing is. Any testing that you do it that doesn't have a user interface. interacting with it. And typically, this is done during the testing phase of software development lifecycle. And it is performed by the testing. Okay. Now, in addition to this, there are a whole bunch of other testing that people are going to perform. So let's take an example. About 99% of times when you're going to build the testing now, it's either going to be web-based or a mobile application. Right? Very rarely you see anything that is built that is not accessible through some web browser. Right? Pretty much everything nowadays you do it is either through the mobile or through the web browser. So majority of times when you go into the real world to do it, your job as a software testing, mostly you're going to do web application testing. So it requires some additional things on it. So when you're doing through a web, right, first thing you need to make it sure is the application user friendly. Can people navigate easily through the application? Can they find the things and functionality that they're looking for it easily into the web page, right? So that thing is known as a usability test. Is it a user friendly? So if you are you naming things consistently, right? So if you like, it's kind of submit request one place and the take action in the other place. And just a submit in the third place. If you're trying to use different terminology to do the same thing for people, it's not going to be easy for them to understand, right? What do I do? Do I submit the application or do I just hit the submit? Or do I save? I don't know, right? So making it consistently is the first aspect. So you may be testing it is that is the system behavior is of user friendly. So it's easy and intuitive. One of the biggest example you see it is in Apple. Right, so when you look into iPhone or iPad, like even 2-year-old kids can navigate and play around with this, right? They don't need a user manual. Right, Sora is laughing, right? You've seen it, right? 2-year-old kid can go figure it out how to play the games on it. Right, that's a user friend. Because made it very easy and intuitive. That kind of testing you do, is it easy to find things? The next aspect is a functional testing we talked about, right? Does it work as expected? Right? Because it may be most user friendly, but it doesn't even work the way it's expected. It's useless, right? So you need to make sure that the functional testing is working. The next aspect you need to start thinking around is compatibility testing. Okay. So in the olden days, when people were building applications, they always knew what environment it's going to run. Right? It'll be on, if I'm a company and I'm building an application that's supposed to run only on for my people, right? I know what environment they have, what kind of computer they have, what operating system they have, and what browsers they're using, and so on. But when I go into the web world, when people, like, let's say if I'm kind of building an application like Amazon, right? I don't know what the end users are having. Are they using the Mac? So are they using Safari? They're using Chrome? They're using Microsoft Edge? I don't know what browser they will use. So I need to make sure my application runs on all those browsers. Let alone, I need to also think about what version of the browser they're using. Are they using Edge 11? Are they using Internet Explorer? I don't know what they will be using. So I need to make sure my software works on all those browsers. Like that's known as compatibility testing. Does the application runs on all operating systems that is intended for, and all the browser version that is intended for? Now we can't test every browser version in every operating system, right? So you may put in the requirements that, hey, the system is expected to be used on Windows 7, 8, and 9, or 10 and 11 version, or a Mac XYZ version. So now you have a bound. So you need to make sure you test all those different versions and make sure the system works on them. one of the most common things people make a mistake on building an application, if it's gonna work on a Mac versus on Windows, as well as on the phone, they implement a right-click function. Right, so if you're using on Windows, right, and a browser, you still have a right click, you can do that. But if I'm accessing that from my phone, do I have a right click on my phone? Don't, right? I have just single touch. So if I implement a whole bunch of functionality, which is a right click functionality in my application, and somebody accesses that from their phone or from a mobile browsers, they can't access any of that functionality. It's gonna fail, right? So that's an important, you need to make sure there is a competitive testing done. Then there is a database, right? We talked about the backend testing, right? Certain things will be only in the database. So if somebody say that, hey, I executed this order by adding the item into my shopping cart and then purchasing it. The website says, yeah, it successfully purchased it. Did it actually did that execution in the backend or not, right? I need to make sure that the database testing or backend testing validates that whatever functionality has been talked on the front, it's also executed properly. Then there is a security testing. So if I'm using anything which has to do with financial data, and I'm gonna provide my personally identified information, right? Like my social security number, my name, my address. You wanna make sure all of those information is encrypted and secure. Right? You don't want people to just tap into your traffic on your Wi-Fi point and read everything that you're sending it, right? So you need to make sure that there's some sort of security aspects of the application. Another example is, hey, I wanna make sure if I'm logged in as a dealer user, I can submit credit application, but if I'm logged in as a system site administrator, right? I should not be able to submit a credit application or approve a credit application. So those aspects of security that you need to look at. Can people tap into it and break into it and spoof the data? And the last type of testing that you also need to think about is the performance testing. Is the system responding your time within that specified time frame, right? When you look into our requirement, it says that, hey, it should respond for 99% of transactions less than 2 seconds. Is it responding in 2 seconds? Because it's an important, right? Think around Black Friday experiences. If it takes you forever to submit the order, what is the normal reaction is going to be? People is going to give up and says, this is not working, I'm not buying it, I'm not doing it. Right? That's the performance testing. If the system is not usable, does not work as expected, or is not performant, people are going to give up, they're not going to use the system. Okay, and as a quality assurance person, you're responsible to make sure whatever those parameters defined it into the requirements document, system is working accordingly for all of those aspects. Okay, any questions? Okay. Let's take a break. Right, let's take a 10-minute break. What time it is? Right, so it's 10:31. Let's go to 10:40. Stretch your leg. To the bathroom, get the water, whatever you need it, and we'll start back at 10:40. Okay, so Swati, we're gonna take a 10-minute break. And we'll resume back at 10:40.
Okay, thank you, sir.
No, awesome. Swati, are you back? Swati, are you back? Can hear you. Alright. Let's get started. Stretching the leg, there's a plug right behind you. Alright. So one of the things that we talked about it is as you test it, right, you find a bug. That bug needs to be fixed, right? So there is a whole life cycle management around the bug, right? And then the entire thing calls a defect life cycle. Okay, and the whole discipline that talks about how you manage it is known as software defect management. So what is your goal? When you're trying to trying to do a defect management, first you need to understand what are the defects. Okay, what is the life cycle it goes through it, and how do you track and manage those defects? Okay, so a defect is essentially an error or a flaw of the behavior on the computer program that produce an unexpected result. Okay. In the behavior is, it is giving you output or the results that are different than what is your expectations. Okay, so perfect example is, let's say if I'm trying to do a calculator testing, I'm trying to do an addition function testing. I do 2 + 2, right? My expected behavior is I should get 4. But if I get a 5, that means it's a bug, right? I was expecting 4, I get a 5, that is a incorrect or unexpected results. Okay. This is known as software bug. Now, the key factor you have to remember is if the software is behaving it different because there was no clarity in the requirements, that's not called a defect. If you didn't specify what the software should do, right, then you should not expect it because you didn't provide what it will be the behavior. And that's an important thing, right? A lot of times people characterize that, hey, system should behave this way, but if there is no requirement specified that system should behave that way, and system behave differently, that's not called a bug, right? Because there's a missing requirement. For example, if I'm building a house, and I said, hey, it should be a 4-bedroom house, but I didn't specify that it should be a 2-story. And a builder builds it, all the 4 bedrooms on the first floor. I go back and says, no, you didn't build it according to specification. Is that a builder's problem? No, right? Because I didn't specify that it should be 2-story. I say that just build a 4-bedroom house. So that's a lack of requirement. That should not be considered as a. Okay. So that's why it's an important as a software quality assurance person that we ground ourselves based on the requirements document, because that is what you're testing against. That's what the behavior that you're expecting it for the system. Okay. Good with that, everybody? Understand what the bug is and when something is not a bug?
So for a software bug to occur, there must be a specific requirement.
Right, because it is a behavior different than what is expected behavior. Right, and in order for me to understand what it should be expected behavior, I need to have a requirement. Right, so that's why it comes from. Okay. So what is the life cycle? Let's talk about it at a high level. What is the software defect life cycle looks like?
So,
Mhm.
so do we have, what are the kinds of, defects, management tools?
So we go on to that. We'll talk about it as we go through.
Oh, okay, so,
Right, first let's understand how the defect is managed, and then we can worry about it.
right,
Okay. So let's talk about normally how things should work. Okay, you are testing the software. You found behavior of software that is not in compliance with the requirement. Okay, so what are you gonna do? You found a defect. Right? The first thing you're gonna do is you're gonna open it, right? You're gonna record it somewhere that there's a defect. And then what are you gonna do is you're gonna give it to somebody in the development team. Or in the project management team to review it, that, hey, I found this issue that is not in accordance with the behavior. Somebody needs to take a look at it and identify who's gonna go fix it. Right, so I'm gonna assign it. And then once I assign it to somebody, they're gonna look at it and say, is it truly a defect? Or is it not a defect because there was a clarity, and then my understanding as a tester is different than what should be. Right, so it may not be a defect, right? So they look at it, they verify that it is truly an issue. If it is truly an issue, they're gonna say, it's okay, development team, you need to fix it because this thing is not working as expected. So they give it to development team. The development team takes a look at that. And says, yeah, I can reproduce it, let me fix it. They fix it. They give it back to you to test it. Right? Once they fix it, they say it's ready to be tested and give it to you. Right? What is you gonna do? You're gonna do it as, okay, let me put it in my schedule, I'm gonna test it back. And when I test it, I'm gonna verify that, yeah, it's fixed. Or it may be, I verify and says, no, it's not fixed, it's still broken. Here is what's broken, and you send it back to them. Right? You keep doing that till it gets fixed, and it says, okay, now I'm good, it is expecting is that. Right? So that's the normal thing, so let's look at that, that's the life cycle. Right? So if you look in this, you found a defect. Right, you record it, so you open it. Somebody else gets assigned and says, okay, this is the defect that testing team has identified, you need to look into it. They look into it and said, is this an issue? They said, no, it's testing team's understanding is not right. It should behave this way only. Then it's gonna be rejected. But if it's true defect, they're gonna say, okay, somebody in the development team needs to fix it, right? So they go ahead and fix it. Once they fix it, they flag it back and say, now it's ready for you to retest it. So it comes in your queue. Once you verify this is fixed, yes, then you close that, saying that this problem is fixed now. If it is not fixed, you just say, no, it's not fixed. You open it, you go back and you kind of go look at it again. Okay, so you keep doing this till you move the defect from here to here. Okay, that's called a defect lifecycle. Now you talked about the tools, right? I don't have to use a sophisticated tool. I can just simply send in an email or put in a Word document or Excel document and track it. Or I can use it there's a lot of something known as application lifecycle management tools now, like Azure or Jira and all of those. It has a built-in defect management. So you just use that. So it depends on what development team and what the company where you're working on a project has it. Right, a lot of applications and the development environment is coming into an integrated environment where defect is right managed. Okay, what is the goal? Okay, when you're looking at the defect management process, your first goal is to prevent defect from happening. Okay. Don't want it to be, right? But if it does introduce, then what becomes? Then your first goal is to identify as early as possible. And once you identify, your responsibility is to make sure its impact is minimized or impact is mitigated. Okay, so any defect management process, you're gonna have those three goals. Okay. As we talked about, right? As you go from one phase of software development lifecycle to another phase, it becomes more and more costly. Okay, here is the data. So back in late 90s, they actually did an extensive study around all of the defect management and says how much it costs us to fix a defect. And this is the data. So if you identify something is not right in the requirement phase, probably it takes you about $1 to fix it, and relatively, right? So. But if you let it go from a requirement to design phase, it's gonna cost you a little bit more. It exponentially starts increasing the cost once it goes into the coding phase. Because then people have to rewrite it, then you have to relook at it, the design, you have to relook at it, make sure everything gets fixed right. It becomes a test, it costs you about 10 times more than something that you fixed it in the requirement phase. So if you identify something is not consistent in the requirement phase, versus you identify that in the test phase, it's gonna cost you 10 times more to fix it. Okay, and it becomes almost 100 times expensive if it goes into production. Right, and this jump is significant because once it goes in production, now you have to worry about the reputation risk. Right, so let's say if I'm a bank and I release a new software that enables people to move the money from one account to another account. Okay. It took the money out from one account, but didn't deposit in the other account is the defect. Think about it, work that if it goes into production. I'm gonna have an unhappy customer who may leave the firm, go to another bank, right? So I'm gonna lose the business. My name is gonna be tarnished, and so they can't get it right. They're not trusting that anymore. Right? Third thing, they have to go back and look at all the transaction where things didn't work properly. You're gonna fix it, right? That means a lot of people has to do manual work, there's no audit. Right? And there could be potential fine also by the regulatory agencies. Right? All of those costs gets added into this one. Right? So as a quality assurance, your goal is to find as early as possible. Right? If you think about, hey, I'm gonna run the test cases, you're gonna find the defect. Realize it. You already have increasing your overall project cost significantly. Versus going down, right? So that's why you always look through the requirements lens first. And that's why the quality assurance process starts right in the analysis phase, not in the testing phase. Okay. What is the overall management process, right? So think around, it's a continuous feedback loop cycle. Okay. So you may have some process in place. Namely, like we did a review process, right? The requirements review process. You may have that process in place. You set the baseline, that means you say, okay, when you review it, think around this, here are the 10 criteria you need to look into it when you're reviewing the document. That becomes your baseline. Okay. As you go through it, right, the system goes in, you identify the defects, and you look into it, says, hey, we had all those 10 criteria to review it. What did we miss? Why did the defect came in? Right. So you look into, once the defect is found, you try to resolve it. Right, obviously you need to fix that defect first. Once you fix it, you do the root cause analysis to figure out what could I have done it to prevent that defect. Right, so you identify the process improvement, and then you go back, and then you add into your defect prevention process. And the next project goes through that cycle, now has an enhanced defect prevention, because they have a new baseline. Okay, the goal is, with this continuous reporting and continuous feedback, you're constantly improving your defect management process. Okay. Now, once you do that, right, the aspects of defect discovery to the tracking, resolution, and making sure what we can do it back into that's a defect, right? So this is the process for tracking that from the beginning to the end. Right? So it's not just simply when I test it, I create the defect. But when I review the document, right? At that point, you say, hey, 10 requirements that was there was incomplete and inconsistent. What can we do in our discussion process with the interviewing customers where it becomes a consistent? what can we do it to make sure it's complete? Right, so that becomes a part of your defect tracking also. Right, so you're not introducing the defect only at the testing phase, but as you go through the requirement analysis and review. Okay, you talked about the tools, right? So some of the tools, access officers, right? There are maybe some standalone, but the industry is moving more towards what we call as an integrated lifecycle management, where defect requirements, testing, development, all is integrated into one tool. So you can quickly correlate it and identify the overall. If you track your defect in an individual tool, compared to the way you're doing the development, you have to do a lot of manual connections to understand the impact of that. Right. Essentially, anything which is a good defect tracking allows you to record the detailed information on the defect. Okay. So let's talk about what kind of information you need to track it for the defect. Okay. There will be always some sort of description of what the defect is. Right? Obviously, if you are putting into some sort of tool that will have ID, so you can uniquely identify each of the defects. Right? But more important thing is you want to identify what is the source of defect. Right? So it is what phase, what activity that you did it. Right? And if you're doing your testing, then you want to say what test case produced that defect. What was the data that you used? Right? And what is the behavior that you saw? And then also identify what are the severity and priority. Remember what we talked about? Critical, high, medium, low, cosmetic. Right? And the priority is high, medium, low. If I don't have time to fix all the defect, which is the first defect that you want me to fix? Right? That's the priority. Right? Severity is what is the impact? How broad or is the impact of this? Then obviously we went through the life cycle. What is the status? Like the new open, ready to be fixed, closed, reject, all those status becomes part of it. And you want to be able to track it, the date and time when the defect was identified, as well as when the changes are needed to the life cycle. You want to talk about the detailed description. Well, what was the reason why you called it as a defect? What is the behavior that you observed it and how it is different from the expected behavior? Right. You also want to talk about what are the steps that you perform in order to do that, so that development team can follow the same steps and replicate it. Right. If you say, hey, it's not working, and it's that the only description you give it, is it helpful for them to figure out what's not working? Probably not, right? So you have to say, hey, when I was trying to log in, I provide the right user ID and password, but it doesn't allow me to log in. Now that's much more specific for them to take it. Okay, anything that you do it for anything screen printing, logs, outputs that you can record it, it's helpful, right? Somebody can look in and say why this is a problem. We talked about once the defect is open, it gets assigned for somebody to look into it. So having some information, who is currently working on this defect, that's useful information. Okay. The priority, something that you can read through it, right? But essentially, which says, what is the impact? Should this be fixed first or should this be fixed last? Which one is more important to fix it first? Right? Based on the high, medium, low, right? For example, if your system is not tracking your social security number, doesn't allow you to enter that for a credit application, that's in a high, right? Where it says, hey, it captures all the information, just displays the date instead of month, date, and a year in a different form. It's still capturing it, right? It may not be as important as missing social security. Then severity, we talked about, right? How much is impact? What is the impact of this defect into overall testing, overall system, and overall users value? It goes through it, right? From critical all the way to cosmetic. Cosmetic is something that hey, if I don't have time, I'm not gonna worry about fixing it, because system is working, there's no financial impact or no user behavior or experience impact. Okay. Then you talk about, from a defect management, some sort of reports, right? Typically, when you start doing testing, you start doing it as what is the daily defect report, right? How many new defects were found? How many were fixed? How many is still to be tested? Right? Where it is distributed, right? Which component, which functionality of the system you're seeing more defects? How many detected versus corrected, right? Because if you're detecting more defect than the more getting fixed, what are your chances, right? Because you keep adding more and more that needs to be done work, so you're not gonna meet your timeline. Here is an example of the defect report. This is not comprehensive, right? I try to like it to minimize it to show it on a one page, right? In reality, when you look into the defect system, it's gonna have all those attributes that we talked through, right? But this is a quick glance of the defect, right? We talked about the ID, what is the status? Which component it is in? What is the severity? What is the priority? What is the timing, right? When it was identified first, when it was last changed, and what is the description, right? Just by looking at it, right, you can just say, hey, if I have to fix it first, which defect you will fix it? So if I call it like it's Pujia, you are in charge to make a decision which defect we need to fix it first, which one you will pick it here,
High priority, critical.
right? So you will look at high priority critical, right? So compared to fixing this one, you will look into fixing this two first, right? And then you will say, hey, look, this one has no changes since this date. So I would rather just try to look into this, right? So those are the kind of decision you make in that. Once you identify the defect, you have to do the impact analysis. Right? So it's not just good to say, hey, there is a problem. Like, well, what is the impact of the problem? Okay. So you're to do analysis, right? And the analysis contains that how long it's going to take you to fix it. How many tests you're to re-execute it, right? Because remember we say that when somebody fixes something, you need to test it to make sure they didn't break anything else that was working before, right? So I may have to do a lot of regression testing. Well, how much of regression testing do you do? How many additional tests that was failing it that you're losing to it? Right? And when you do that, well, what is the impact of other planned activity that you had it? Because now this is unplanned, now you have to replan it. What is the impact on it? Right? And what is the impact of the project completion timeline? And sometimes you may not have a opportunity to have a flexible time, right? For example, right, your federal tax return needs to be filed by April 15th. Right? If you find a defect, and then say it's going to take me like 2 months to fix it, and you found that on April 1st. That timeline is going to go past April 15th, right? That may not be feasible, right? Because now all of a sudden you're making a whole bunch of your user base to refile it or put an extension request, right? That's a huge impact. Versus if you say, hey, I can minimize this impact, it's cosmetic, it's okay if people don't get it. That they're still able to accurately file that extra term. They may be seeing it like it's, hey, my logo is here, and then at the top right instead of top left, big deal. Okay. Any questions on the defect? Do you understand what it means? Okay. So what we're gonna do now is we're gonna start looking into, if you have requirements, how do you go about thinking around scenarios, thinking around test cases? Okay. So I'm gonna switch this. Okay. I'm gonna tie the whiteboard. So the time of all the lectures and foundation is done. So from this point onwards, we're gonna spend more time actually doing what we will do on a day-to-day basis. Okay? So I'm gonna go ahead and open a whiteboard. So. Okay. So think around it, right? So if you have a requirement. Okay, something like as a user. Want to be able to log in into. Right? Okay, does this make sense? If somebody gives you a requirement like this. Right? So we talked about our flow. Right? And say as a user, I want to be able to log in into our flow. Okay. And then as for login, what do you need? User ID and a password. And say, if I want to test it, if this requirement works or not, what are the different things that I need to think about? Right? So what are the possibilities if I'm like it's kind of trying to do a login into any system? What are the possibilities? Have user ID and password, right? So one possibility is I'm going to give you. Let's just keep it, right? So I want to give a valid user ID. And a password, right? That's one scenario, right? That's a positive test case. Right? Alternately, somebody could type it a valid ID. The wrong password. Right? So I need to, if I'm testing it whether the user is able to log in or not. I need to test the scenario to make sure. In this case, the user will be able to log in. In this case, they should not be able to log in. Right? What is the third scenario? I give invalid ID. Right? And at that point, whether I have a right password or wrong password doesn't matter, right? If I didn't have an account, let's say I take an example in a bank, right? If I don't have an account in the bank and I don't have an ID, it doesn't matter what password I give it, right? I should not be able to log in. Are you with me so far? Right? Another scenario people may try is, hey, what if I try to log in without providing user ID or password? Should I be able to log in? Right? So there is no data. Right? So if I look into this, in this case, I should be able to log in. And in this three cases, I should not be able to log in. But in order for me to successfully say that a user is able to log in only when they have a user ID and a password, I have to test all these four scenarios. Right? To do that. So this is something known as a tree. So you take a requirement and you identify a scenario tree like this and says, in order to do this test, what all scenarios I need to run? In this case, I have to write all these four cases in order to test it successfully. If any one of them fails, is the system working as expected? No, right? So if I'm able to give you a wrong password and still log in, obviously my security is not working as expected. Right? Same thing with the invalid ID. If I give you an invalid ID and then just log in the system. Or sometimes you might say, hey, you know what, I tried clicking 3 times to log in without providing any data, the system let me in.
Mhm.
That's a security issue, right? So you have to prove that in this 3 scenarios, I can't log in this scenario, I can log in, then only my requirement works as expected.
What about like when the username is your phone number and like?
But that's still an ID, right? As
What
long
if
as
like
it's a valid ID.
the code doesn't come? Like, you know, those situations where they send you a code in your.
Right,
phone?
but in that case, right, that's a 2-factor authentication.
Uh-huh.
We are not even going in that complex, right? This is simple, user ID and a password.
Mhm.
Now that adds additional scenarios because it's a 2-factor authentication. Right, but for now, we're keeping it simple. I'm able to log in using user ID and a password.
Mhm.
Then what do I need to run? These are the 4 scenarios that I need to think about. Right?
Mhm.
So every time you get a requirement, if you're a quality assurance person, first thing you need to think about is how I'm gonna test it. And in order to test it, what all different scenarios I need to test.
Mhm.
Right, so that goes up. Okay. So let's take an example of the R4 requirements and let's walk through it. Okay. So I'm gonna try to pull. I'm gonna do it. One of the search requirement, right? Okay. So. So let's talk through this requirement. Okay, and as a team, let's walk through it. Right. So. You all read the requirements, right? I just pulled it up from the document, right? So whenever you look at this requirement, what is the first thing you have to do? Or did I ask all of you to do it on Thursday?
Mhm.
What test I asked you to run? When you read the requirements document, I asked you specifically to do one thing as you read the requirement. What was that thing? You guys need extra coffee? Or you need a confidence boost?
We'll see if, what are they asking?
What did I ask you to do it whenever you read the requirement?
You test.
What test I asked you to do it? 3C
Oh,
and a T, right? What does 3C means?
complete.
Complete consistency
Consistency.
and correct.
and correct.
Right. So let's look at that, and let's apply. Okay, do you feel this requirement meets 3C? Because before you put together a scenario, right, you need to make sure you understand the requirement, right? So do you feel it's correct first? Let's start with the correctness. So when you read it, do you feel that this requirement actually belongs into this document? Right, because you're doing a dealer search, right?
Yeah.
And this system is around the dealers and lenders, right?
Mhm.
So it's probably correct, right? So it belongs in here.
Mhm.
What about consistency? When you read this requirement, did you feel that A, it is, if it is multiple places in the document, is it similar or same at every place? Right? So you read the requirements document. Is there anywhere else that talk about searching a dealer? No, right? This is the only place that they talk about it. Right? So it's probably consistent. Now let's talk about the third aspect, is it complete? So when you read it, and if I say it's, as a team, go ahead and test this requirement. Do you feel it's complete? Do you think you have all the information needed to test it? Is it complete? Well, this is supposed to be interactive, right? I cannot do it unless you feel it is that this is complete or not, right? What do you feel? Is it complete from your response?
Yes.
I feel it's complete in terms of what existing.
Okay. You feel it's complete, okay, that's good. So, if I have to start thinking around tree. Right, I need to, so if this is complete, right, so I can look at all the different scenarios I need to develop. So, let me ask you a question. When somebody says that you will be able to search an existing dealer, that part is good. Right? But then says, what criteria am I going to use it to search? It says dealer name, address, and etc. What does etc. mean?
And so on,
So,
so on.
So on, what is the so on means? What other are attributes? Tell me what is so on means. So if I have this requirement and I do something and I say, okay, let me search by how many employees they have. Is that right? So what does so on means? Is it a complete requirement? Do you have an understanding when somebody says ETC, what else, what other criteria do you need to use it to search on?
They're, what county they're in, all those things.
So rule number one, whenever somebody gives you a requirement, you don't assume and you don't put your own requirements in it. So when you say it, oh, what county they are in and that. Is that the requirement or is something that you thought is a requirement? Okay. So let me give a reality example. Right? So if I'm building a house,
Mhm.
right, and I told contractor that, hey, I need a house, build a house for me.
Mhm.
Okay, and I didn't tell them that, hey, I want it like it's 5-story house with 10 bedrooms.
Mhm.
Builder says, you know what? You said you just want a house. Let me build a house, which has a 5 stories and 10 bedrooms. And then they give you a bill for that. The things that you didn't ask for, are you gonna pay it?
no,
No, why? I thought that you need this, that's what you stated, I thought you needed search by county,
So it's not clear.
right? So as a first rule, as a quality assurance person, you don't put your own requirement.
so that's-
You go with whatever the requirement is provided, and if it is not understood well,
Mhm.
you ask the questions to understand.
Okay.
Who do you ask the question?
the leader, it's in the.
Whoever gave you the requirement, right? Some cases you ask your project manager, some cases your project manager says, you were part of it, just go ask user. So you ask the business, what does this mean,
Mhm.
right? So in this case,
What does
you have an
accept?
understanding what does ETC means. You don't have it, right? So you ask your business users, right? So we're gonna play a role play, we're gonna make Herschel a business user, right? So if you have this requirement and you think it is not complete,
Mhm.
what question you wanna ask your Herschel?
What does accept?
Ask him, ask him.
Harshal, what does et cetera mean? What do you mean?
I think when somebody captured the requirement, they probably didn't realize they are adding additional information.
Mhm.
So we just want to limit the search by dealer name and address
Oh, okay,
only. Okay,
okay.
so we'll take out the et cetera.
Okay.
So somebody will need to update the requirement. That's generally before.
All right. So based on that feedback, I took it out.
Yes,
Now, when you read this, are you good with this?
yes.
Do you feel it's complete?
I feel it.
Do you feel it's complete?
Yes.
What about the rest of the team?
Yes.
So are you still thinking?
Still thinking.
What about you, Swati?
I think we have to check for requirement document, business
Right.
requirement document.
This is what is in business requirement document, so if you read this requirement, do you feel it's complete now? We took out the word et cetera, which has ambiguity.
Yes, it's complete.
You
Requirement.
did it. You good?
It's still not complete,
What is not complete?
because when it says search by dealer's name and address, we don't know what the name, I mean, we don't know the kind of what name is, I mean, search by dealer, what name are we looking for?
Let's say Jeremy and Honda is a dealer,
Mhm.
right? So that's their name. What else you need?
It's complete.
I'm giving you an example.
Test data. Test data. You have
Which
to
data?
check for test data required for testing.
Well, the data is different thing, right? I'm saying this is a requirement. Data is gonna create it and you're gonna identify the data. But do you feel that just by reading this, you have ability to test it? Assume that somebody gives you data. Do you feel it's complete? Do you know exactly how to test it? Yeah, let me ask you another question. Okay? So if it just says search by existing dealer by dealer name, comma, address.
Mm.
Does that mean I have to provide both name and address? Or just one? What happens when I provide both? Do you have an understanding what should be the result?
So we have to put an and in between.
Okay. Are you defining the requirements? Or who is defining the requirement? It's a very tempting thing every time, fill in the gap yourself. Don't do that. Those things can cost millions of dollars if you do not be careful. And there are history where people have shown that. So if you ever ask a question, what questions you will ask?
Partial. Do we need to, so the user, it says the user must be able to search existing dealer by dealer name, comma, address. Should it be both or either or? What is your,
It's either or basically, so they can supply if this. If I'm searching for existing dealer, I
Mhm.
should be able to just put in some text and it should search both fields. basically.
Okay.
So add dealer name and
Mhm.
address, anybody matching with that,
Mhm.
that should be written
Okay.
on the system.
So see, his answer came completely different than what we expected.
Yes.
You were expecting it's, oh, I have two fields that I have to provide and I'll put in value in one of them.
Mhm.
Versus what he just said that,
Mhm.
I'm gonna search by only one field.
Mhm.
And whatever text I put it, as long as it matches dealer name or address, pull it up.
Mhm.
Right? Do you feel now it's correct, incomplete?
Yes, as a sentence, it's complete.
Everybody agree it's complete?
Yes.
Okay. So when I look at the address,
Mhm.
address has multiple components. Street name, city,
Mhm.
zip code. What do you mean by search on address? Any or about all of them? Or just by street name? Because he said that it's providing text.
Mhm. So need more context.
So what does address mean to you? Is it city? Is it street? Is it state? Do you have that clarity? So what do you do?
Ask them.
So ask him.
Harsha, what do you mean by address?
Yeah, okay, so as I said, I mean, if they put anything, right, in the search box or whatever the design is, right? But they will just enter the string. It should match anything in the dealer name or address components, basically. So city, state, zip,
Uh-huh.
street address, anything
Okay.
matching with that. And it should pull up.
Okay.
Okay. So any address component, right?
Mhm. Mhm.
So that's what he's saying is in address field. Now do you feel it's complete?
Mm. Like scared to say yes. There's always
So it's-
something.
The whole point is, all of us read the same requirement. You read it different, then I read it different,
Mhm.
right? I need it. So the question is, if given this information, do you feel you can test it now? And get an answer, yes or no?
Yeah, I think so.
Okay, so let's take a leap of faith and say it's, okay, if you think it's yes, think so, let's see. And as you define scenario, if you feel that something is missing, well, we'll go back and ask it.
Yes.
Right, so now let's talk about the scenario for this. Okay, so now that all of these things is there, right? So what are the possibilities? Right? The first possibility is,
We search the
Can you
dealer.
talk about the context or?
no, we'll come through that,
Okay.
okay, let's go through it, right? So. When are you gonna do this,
Mhm,
right? So what are you gonna do, search by dealer name,
mhm,
right? So I want something that matches dealer,
mhm,
I wanna do something that matches address,
mhm.
but within address. I have to think about something that matches
City.
street,
Mhm,
Zip code.
right? Zip code. City,
mhm.
state,
State.
Okay.
Mhm,
then. What else in it? It doesn't match any of them,
mhm,
right?
mhm.
So no match, so I provide something. But I don't get anything. Or I provide no data. Then what should happen? Should it bring everything? Should not bring anything,
Yeah.
right?
Mhm.
Do you understand that?
Yes,
Yes or no?
yes.
So what should it give? Tell me. If it doesn't match anything, it should get no result,
No
right?
result,
But if I didn't provide anything and click on search, then what should it do?
nothing. You didn't provide any data.
Is that the case?
I don't know.
You know for sure, that's what the user wants.
Mm-mm.
So what do? You ask Herschel. What happens if somebody, Herschel, what happens if somebody doesn't enter any data and click on search? What should system do?
It should show the error
It
message.
shows no.
Error message.
All right, so
Yeah.
now it's, because sometimes it may say, show me everything.
Mhm.
But now he's specifying that in this scenario, you show error message. Right, so now you have a complete understanding of requirement, because earlier, you didn't have that understanding. Now that you define the scenario, it says, what should it do it? What should be your expected behavior when they do it? Right?
Mm.
So this one, he is also clarifying that this is a required information.
Okay.
Right, something they have to put it.
Yes.
If you don't put it, you give it a message, please enter something. Good,
These are like basic things, like.
but nobody asked me that question and I asked it.
Yeah, so we have to look at every single thing, like,
Yes.
okay.
Okay, so another important thing, now that you understand the requirements, do you have an understanding who will be doing this work? Is it site administrator, dealer, our front rep? Who will be using this requirement? Who is the user here?
Customer.
What customer?
Business users.
But who is the best user? So Swati, you haven't had an opportunity to read the document, right? But there are different users defined in the requirements document, right? So if I go back to the requirements document here,
Yeah,
Right.
phone.
right, hang on, right? So here is the type of users, right? When, what a user is that referring? This requirement is telling you, right, the user. Is it your site administrator, is it dealer, lender, rep, area manager, regional manager? Who is this person? Who is this user? They just said user, right? You said, hey, I understand everything. What is the context? Which is the user?
We need to ask Harshal.
Do you need to ask Herschel or do you need to understand the overall end-to-end process? When is this gonna use it? Let's just talk about it, right? Let's step back. When do you think this requirement comes into play?
Mhm.
Okay, let's talk about which component this is. This is gonna be part of dealer management, right? Agree?
Mhm.
So you eliminated anybody who is not able to do dealer management will not be the user here, right?
Mhm.
Agree?
Yes.
Okay, so. Now that you know. Anybody who will be able to do the dealer management is the users, so when they would be using this requirement. You remember the processes? Right?
Mhm.
One of them was creating a dealer, right? So when you're trying to create a new dealer, first you need to make sure that the person or that dealer doesn't exist in the system, right?
Mhm.
So what do you do it? You check it, look it through it, is the dealer exist or not, right? And in order to do that, you need to probably search by that. Right? So it's important to understand where this requirement comes into play. Right? So you did the 3CNT.
Mhm.
Right? Sometimes you do that first, or sometimes you understand the context. When is this gonna be invoked? When is this requirement gonna happen? Okay, then you understand, do I have all the information in order to successfully test this requirement?
Mhm.
Right?
Mhm.
Everybody clear? Now that you understand the context, okay, somebody will use it when they are trying to create a new dealer, right? So managed dealer functionality is only available to super user
Mhm.
or your RFREP or area managers or,
Mhm.
right? So your user is gonna be either super user or site administrator or any one of the area reps or RFREPs, right? Those are gonna be users. So when you are running the test, you need to log in as one of those users. Then you need to run the test, right? Now, let's talk about the tree. How many unique test cases down here to think about? A dealer? Address? Right, no data, no match. Is this sufficient or did I miss any scenarios? What if I have a matching with both the dealer and the address name? So one dealer, let's say if I just say it's Dublin,
Mhm.
right? So it will match German Honda of Dublin. And there is another two dealers in Dublin. All of them match. Should I get all three of them as return results or should I get only one? You said it's only one? Let's confirm with the end user, so Herschel. In those scenarios, right, where my both dealer and address matches. Should I return all of them or should I return only one of them?
You should return all, because it's, if I'm searching for certain things and it matches multiple records, then it should pull up all the records.
So it's not just one, right? Anything that matches it, he wants to see all of that list,
Mhm.
right? So now I have to think about not only just if only the dealer matched or if only the address matched. But I want to say, what if the dealer and address matches? Right, so I have to do all those scenarios. So now this is called a tree. Right, scenario tree. So how many unique test cases I'm gonna end up writing? I'm gonna write up, one is dealer and address matches. One is only if the dealer matches. Another one is if only the street matches, only the zip matches, only the city matches, only the state matches. If there is no match. And then there is no data. Right? So at a minimum, I have to write 8 test cases. In this 5 scenarios. Right, now you can go further and say, you know what, my dealer and address, what if it's dealer and street matches, what if dealer and state matches, what if dealer and zip match? You can further define also. To define a much more specific data. Right, but in order to test this requirement, now think around it, this is where it comes. Solar, when you were talking earlier, 1 week versus when I was saying, it's gonna take you 3 months to test it. Right, because now you have to write all this 8 test cases first. So it's gonna take you some time to write that test cases, then you're gonna execute it, all of that. What if one of them fails it? Then you need to retest them. Even though it's only one requirement. Okay, any questions on this number? Does that give you a sense of what you need to do? If somebody gives you a requirement, now we are progressing towards how I'm gonna test about that requirement, right? The first thing I did is to map it, is it 3C? And then in order to do the T, what all I need to do it, right? So if the requirement is not complete, consistent, or correct, should not even try to go through it. Sometimes when you start doing it, you may think different things. And that's going to prompt you a question, is it really correct requirement? Is it really complete requirement? Okay. Anything before I pause on it? So you'll be able to do it for every requirements now in the requirements document?
Hopefully.
Oh,
I have
so
a
let's,
question.
yes,
So if a requirement is not consistent, is not correct, is not complete, what do you do?
what did I do?
No, what did you, I did not say what did you do, what would you do? Are you gonna test it, go ahead and test it, or you have to?
What did I do? I asked Herschel.
So you
Help me
always get
understand
clarification.
complete, right? So you go back to your business users
Okay.
and says, make sure it's complete, understand. Because if you don't do that, remember the defect management?
Yes.
You could have many defects.
How many you're gonna go? Tenfold, right? If you catch it in the test. So I don't even wanna do the testing. Till I have a better understanding. If I don't have understanding. What am I gonna do it by testing? Because it's gonna be incomplete anyway. Right? It's important for me to make sure I understand it completely. Before I go into that. Make sense?
Yeah.
Because we just did that here, right?
Yes.
Partial played a business user. And we as a testing, we didn't have a good understanding, so we asked them a question. To get that clarity. Does anybody write the software yet? Nobody has written software, right? Did anybody have some test cases? No, we just identified what test cases I need to do. So it's something that we fixed it by just talking to him in 2 minutes. Which would have taken it, if I wrote the code and tested it, now. I have to go and fix all the code, I have to write additional test cases. Because it may not be complete for me. There's a lot of test cases which I have written it that failed it, that's no longer needed. Because earlier our understanding is 2 different test search fields. That's how we implemented, we have implemented test that. Right? We may have just said is, hey, it could be a dealer name and address. So we will always get the wrong results. Versus he clarified it's either or. It's not an and situation. Okay,
So how do we get to find out the user, who the user is?
that's what the question, that you got to understand the context, right? Which says, when is this going to be used? Based on that, it says, okay, who all can be using it then? Right, so we eliminated, there is no lender. Right, there won't be a dealer, well, if I'm a dealer, why would I search it myself? I already know who I am. Right, it'll be somebody else who is trying to access me will be searching it.
So you need to understand the business process, okay? That's very important as a QA. When does this requirement come into play? You have to wear that user's hat because you are simulating that user. Before they start using the system.
The context of when this will be involved in the system, so when this particular functionality will be accessed by whom. and for what purpose, it's the most important thing, and that's what Herschel is pointing out. Make sure you understand the business process, and in which business processes requirement will be invoked. So that context is important as we go through it, right? And then that's the process you go back and forth. Sometimes you will get all of those clarity first before getting into this. Sometimes you start putting the thoughts and then ask your questions. Okay, do I have understanding of users? Do I have all the scenarios to run? Right? Because you may have to use now, think around the execution or testing point of view, right? Now, there are multiple users who can do it. Site administrator and our friends. Let's say just two of them, right? Then you have to execute this test scenario for both of them to make sure they both can do it, same thing. Right? Because there are two different users, right? So you have 8 test cases, right? And you have to, let's say in this case, you have 4 users, right? Our rep, area manager, site, the regional manager, and site manager, right? So technically, you have to execute 4 times 8, 32 times you have to execute. All you have to do is change the different users and making sure it works for all the users. So your number of test cases you may have to execute is 32 in this case. Right? But 8 unique test cases, just different users. Okay? Any questions? Okay, so now let's apply your understanding of building a tree. So what you're gonna do, I'm gonna put your requirements, and I want you to spend 5 minutes, build a test case. Or I'm sorry, test 3 scenarios. Okay, so let's pick a requirement. Let's go try to. Let's keep it simple one.
Keep the password.
So you want password, let me hold that.
Yeah.
Okay. So
It's part of managed user, okay, that puts out.
Okay, 2.62. Okay,
this is the requirement. Okay. And I picked it up from manage users. Okay. So let's take it, it's 11:46, so I'm gonna give all of you 10 minutes to think through it and build the tree, right? So take a pen and paper on your notebook, right? Draw a tree. And then we'll talk through it. Okay, Swati, did you understand the exercise we are doing it?
Yes, yes.
So this is the requirement. It is in the context of managing the user. So I want you to think about it. Is it complete? Is it correct? Is it consistent? And if so, can you draw a scenario tree for this one? How many test cases you need to run it in order to test the scenario? Okay, so 11:47, I'll give everybody time till 11:57 tonight.
That's it.
All right. So let's talk about, who wants to talk about when is this requirement going to come into the play? So essentially, when this thing is going to come into play in the system.
when the user is logging into ArcZone,
So when the user is logging in, what about others? Do you think this is gonna come into play when the user is logging into the system?
It comes into the system when you have the valid password that requires the one uppercase or special.
But when it will, like, when you say valid password, when does valid password come into play, right? Would you just say that like, hey, I need to do that when I'm logging in? Okay, does everybody agree that this is when I'm gonna use this requirement, logging in?
What's the context? of the
Right.
requirement?
When is this requirement gonna come into play?
What module, think about what module it is.
You saw it, right? It's part of manage user.
The user must be able to search
Okay,
existing.
so let me ask you a question. When you're logging in, right,
Mhm,
you're providing a password, right?
yes,
Is that the time when you are making it sure it's one uppercase, or all you're doing it is when they're logging in? Is the password matches to whatever is in the system says that the password is?
I think they need to understand
You
what's
must
the
know the
purpose of.
requirement first.
Huh?
You must know what it requires.
Right, you must know what it requires, right?
Yeah.
So typically, when do you use it? Like, you all logged in into the various things, right?
Mhm.
When you create an account, that's when you create password, right?
Yes.
And when you create password, that's when they enforce you, hey, it needs to follow this rule.
mhm,
Right, what is this? This is the password rule, right?
Yes.
What should be your password? So what is the context? Is it when I log in or when I'm creating my user ID and password first?
So you are creating a user.
When I'm creating user ID and password, right? So it's an important to understand the context. It's not when I log in, it's when I create it.
create,
Good. Everybody agree?
yes.
Okay, when I'm gonna create it, who is gonna create it? Talk about the context. You read the requirements document. So when this is gonna come into play?
Think they do it one more time.
No.
Site
Remember, logging in is too late. That's not when you're creating the password. When are you creating the password? What module? Let's start there. What is the module where this requirement is placed?
admin.
You must have the-
What is the module where this requirement is?
2.6,
What is the module name? Can you read it for me?
manage users.
Manage users.
What happens in the manage user?
Right, what do you do at the manage users?
What's the process, business process? Did you guys look at the business process?
Create a
Yes.
user? Update users? Change users, right?
Yes,
So this is the requirement. Specification, is that associated business process,
mhm,
right?
yes,
What is a business process?
setting up users for our phone,
What is the process? Business process two, right?
yes,
That was a mapping from that module to this, right?
yes,
What is this? When does this occur?
new user needs to be set up. Mhm,
So when is the new user is going to set up in the system? And what are the user type, right? All this in a user type.
mhm,
Whenever any one of this user sets up,
mhm,
that's when you need to create password for them,
mhm.
right? So who all can create users, right? The manage user, this particular row. Anybody has the yes here are the one who can create it, right?
Mhm. Remember.
So it's like a jigsaw puzzle, okay? I mean, you need to put together a bigger picture by looking at the information and, figure out.
Okay.
What's the overall process here.
So everybody understood, right? Context, when this will be used. Right? So when a new user is getting created, that's when this will do it. Okay, and who all can create new user? Those 5 roles. Right? So you need to say it is like, whenever you're trying to test it, you need to log in as one of those 5 users. And you will be creating a new user. That's when this requirement comes into play. Okay? Now let's talk about the scenarios. So somebody walk me through it, how many different scenario trees, just like this one, right, where I draw a tree. Help me draw the tree for this one.
So can I start?
Go ahead.
I
You're to
did
speak it a little bit loud so that everybody else can hear.
I did the 3 Cs first.
Okay,
Checked if this scenario was complete.
okay,
I didn't think it was complete because it says password must be 8 characters and requires at least 1 uppercase and special character. I don't know, what do you mean by special character? Special character can be many things.
okay, so ask the question, right?
Partial, what is special character?
So it can be any special character except. Let me just put it that way. What they shouldn't have it, right? The quotes and double quotes and single quote. How about that if I define that for you?
So the special character is not in upper quotes or single quote.
Otherwise, they
So
can enter.
anything other than that.
Okay.
Okay, does that address all of the questions that you had for incompleteness?
No,
What else you have for incompleteness?
for 1 uppercase, what do you mean by 1 uppercase?
So if I'm using alphabets, right? So lowercase a versus capital A, lowercase b versus capital B. So there's gonna be 26 characters, which are lowercase, and 26 characters, which are uppercase.
Okay.
So what it says is, I have to supply at least 1 uppercase. Okay, that's how you are interpreting it. You need to interpret it as,
Okay.
and supply at least 1 special character.
Okay, then that's good.
At least 1, yeah. You can have 5 special characters, that's fine. Doesn't matter.
Okay, so if I add those 2 contexts, does it fulfill your requirements? Is it complete?
Yes.
So, do you draw the tree?
Yes.
Okay, let's talk about it. What do you have it for the tree?
So the user, first thing the user types in 8-character password, but it doesn't have uppercase or special character.
So 8 characters, no uppercase,
Mhm.
no special case.
Then 8 characters, there is uppercase, but no special character.
Okay,
Next, there is no uppercase, but there is special character.
so 8 characters still,
Mhm.
no uppercase, but a special character.
And next is there aren't 8 characters. There are no uppercase and no special character.
So no 8 characters
No 8 characters, no uppercase, no,
in this one, or it's a separate scenario?
I don't know, it can be all together, I guess.
Okay, so no uppercase, no special characters. Anything else? Other than this 4?
I think that's, yeah, that's good.
Okay. All right. Anybody else? So Laura, Nana, you have anything else?
Yeah, 8 characters. Uppercase, special character.
That's,
Eight
Okay, so you
character,
missed this one, right?
yeah.
yeah.
8 characters, uppercase and special case.
Yeah. Then 8 character and 8 characters. Uppercase, no special character. 8 character. Then no uppercase, special character. No,
Right.
yeah. Same thing,
Okay, so
Yeah.
all of that.
yes.
Anybody else, like it's either yourself, Solar, or Swati, do you have anything additional other than this 5 scenarios?
No data, empty data, or valid. One more is valid uppercase letter, 8 character, and valid is 1 special character. Means valid data. We can make an entry for.
Right, which is this one, right? The one that I'm kind of mapping it, 8 characters, uppercase and special characters, that's the one,
Okay. Okay.
right? Anything else?
Yeah, no data.
Yeah, is
Yeah,
that-
that's what.
Less than 8 characters. Less than 8 characters.
So you wanna break it this down, not characters as less than 8 characters and greater than 8 characters? Okay,
More than one special character.
more than 1 special characters,
Mhm.
right?
And then more than one uppercase letter.
Okay. So 1 plus uppercase. 1 plus special case,
Mhm.
right? Now, are you gonna define it like it's when you say more than 1, it's like, what if it's 2, what if there's 3?
Yeah,
Do you need all of them?
no,
Or it's a redundant case?
I think it's redundant.
So when you say there is at least 1,
Yeah, I mean, it can go underneath that.
this can be redundant, right?
Um,
So this could be redundant. So I'm going to say this aspect is redundant, right?
mhm.
Okay, so what do you have defined, right? I'm gonna do it, so there's a 1,
Mhm.
2,
Two.
3, 4, 5, 6, 7 test cases,
Mhm.
right?
Mhm.
So in order to test this requirement, you could have 7 test cases. Right,
Mhm.
that's one way you can do it. Right, the other way, now there is no right or wrong, right? It's everybody does it different, right?
Mhm.
So I could do it, I start with it. There is 8 characters. There is a less than 8 characters. And then there is greater than 8 characters. Right?
Mhm.
Because if there's greater than 8 characters or less than 8 character, I don't even want to test anything else.
Mhm.
That doesn't meet requirements, right?
Mhm.
If there is a 8 characters, right? Then I can just say, is there an uppercase or a no uppercase,
Mhm.
right? If there is no uppercase, I fail that, I don't have to order because it requires at least 1 special character, right? And I can just do it, there is at least special characters or no special characters. Right? And then I just say it's no data. Right? It's a different way to represent, right? In this case, you're gonna go test 7 different test cases, right? Here, I can do it 1, 2, 3, 4, 5, and 6. Right? There's no right or wrong, right? You could do it this way, build your tree, and says, I'm gonna do 7 test cases. Or you can build this way and say, I'm gonna do 6 test cases.
Mhm.
So it's same requirement. Right? That's why it's important to understand the context, right? You could do it 2 different ways, there's no right or wrong. Both are right, both can write the test cases. Okay. So you went through the process, you understand now what you do, right? So if I give you a requirement, you should be able to walk through this process and do that, right? Now, again, there are 6 test cases, we said there are 5 different user types who could do it, right? So potentially you may have to execute 30 test cases. Depending on the different users trying to create it.
Mhm.
Any questions? All right. Swati, you good with this?
Yes, I'm good.
All right, so let's take a pause here. Today, right, because we made a talk through a lot of things. I want to make sure you comprehend all of those things. Okay, this is what we're gonna do it for homework we're doing now and Thursday. Okay,
Because I think they need to read the requirements again, understand that first.
Yeah.
Right?
so the first thing is read the whole requirements document again once.
What
Make
do
sure
we-
you understand the context. Right? Make sure you go back through the 3C and T,
Yeah.
trying to understand as many questions you have it now,
Mhm.
right? Because when we did Thursday discussion, you didn't have any questions. We did one, you have more questions, right? There are probably more requirements that you may have questions. So understand the requirements, but not only just for the 3C and T, understand the whole context. Get the visual picture of how everything fits together. Okay? I also told you to read the test data, test plan document. That's something, don't need to do it before Thursday. Do it over the next week. Okay? Third thing is, Herschel is gonna send you 3 requirements.
I'll send 5, I'll point out 3.
Okay, so he will send the requirements for you. Expectation is you will create 3 similar to this. Okay,
Mhm.
draw it on the piece of paper if you need it, take a picture, or you can do it in a Word document, right? Or a PowerPoint, whatever tool you're comfortable. Put the requirements, draw it, the tree, share it with it. We're gonna talk through that on Thursday. Make sure you understand the whole process of creating the tree. Right, when you create the tree, just like I numbered it, it's essentially will also tell you how many unique test cases you need to run. Okay. So that's what needs to be done between now and Thursday. Any questions? Okay, Ursula, you want to add anything else?
No, do the homework, make sure you spend 4 to 5 hours during the week, and get it done, right?
So-
I mean, this is important part, the reason we are saying, I mean, we emphasize on this. Because this is important, this is core of your work,
Mhm.
analyzing, this is called analyze, whatever you are doing, the process basically. That's the most important part for you as a QA. Okay, tools are tools, technologies are technologies, you can pick up any tool, that's not a.
If you can't figure it out how to do this, you are at standstill.
Yeah.
You can't write a test case unless you know what you're writing. And this helps you to understand what you're writing.
Mhm.
Okay. And again, this, I can't emphasize what Herschel said it more. Make sure you keep up with additional homework and requirements. Because in a week or two's time frame, this is what you're expected. We'll continue to move it faster and faster.
Mhm.
If you don't have this basic understanding, the building blocks, you're gonna struggle. Okay, so make sure you take time. We're gonna give you enough time this week to work through it. We'll talk through it on Thursday. We'll talk again on Sunday to make sure you understand it thoroughly before we move into the next phase. Okay? All right, then we can pause here for the day.
Yeah.
Arthur will send you the requirements and this video will be accessible. So watch for the video as you go through it. It has all of this diagrams in it, right? So there is the requirements, all the 3 that we did in one place. Okay. All right,
Yeah, you guys are not asking many questions, so we are wrapping up a little bit early. I mean, yeah, but we are still moving, actually faster pace here.